So you're prepping for your exams, WAEC, JAMB, NECO, and you know that there are some topics that are just guaranteed to pop up. Well, today we're going to tackle one of the big ones, water and solubility. If you can nail this stuff, you're going to have a serious edge. Let's get you ready to ace those questions. But let me ask you something first. Ever wondered why a freshly opened soda fizzes like crazy but then goes totally flat if you leave it out for a bit? It seems simple, right? But the answer is pure chemistry. Hang with me because we're going to connect all the dots and solve this exact mystery by the end of this. Okay, let's get right into it. To understand how anything dissolves, we first have to talk about the liquid that does almost all the dissolving on this planet, water. You've probably heard water called the universal solvent, and there's a really good reason for it. It all comes down to one key property. Water is polar. See, a water molecule isn't straight, it's bent. This shape creates a slightly negative charge over by the oxygen atom and slightly positive charges near the hydrogen atoms. These charges act like tiny little magnets, pulling apart the molecules of other things like salt or sugar. That polarity, that's basically water's superpower. Okay, so now we know why water is such a great solvent. Now let's get into the rules that control this whole process. These are the core principles you're definitely going to be tested on. Okay, this next part. You absolutely have to know this for your exam. It's the definition of solubility. It is the maximum amount of a substance, a solute, that can possibly dissolve in a solvent at a specific temperature. Just think about adding sugar to your tea. You can stir and stir, but eventually you hit a point where the sugar just sinks to the bottom, right? That limit, that is solubility. So what messes with solubility? For your exams, you got to know these three main things. First, temperature. Second, the nature of the stuff you're dissolving and what you're dissolving it in. This is where you get that classic rule, like dissolves like. And finally, pressure, which is super important, especially when we're talking about gases. Okay, lean in for this one because this is a classic exam trap. For most solids, like salt, when you heat them up, their solubility increases. You can dissolve more salt in hot water than in cold water. But for gases, it is the complete opposite. As the temperature goes up, the solubility of a gas decreases. Seriously, just remembering this one little difference can be a guaranteed point on your test. All right, we've got the theory down pat. Now it's time to bring in some numbers and do some math. And I know, nobody loves math, but don't sweat it. We're going to walk through it step by step. Here it is, the big one. The key formula you need to commit to memory. Solubility is simply the moles of the solvent divided by the volume of the solvent. But look closely at the units. You have to make sure your answer is in moles per decimeters cubed or moles/dm cubed. That part's crucial. All right, check this out. This is a perfect example of a calculation you'd see on an exam. We need to find the solubility of 40 grams of copper sulfate in 100 grams of water. So take a second, maybe even pause, and think about how you tackle this. Ready? Okay, let's solve it together. Okay, let's break this down. First up, we need the molar mass of our copper sulfate, which adds up to 160 grams per mole. Simple enough. Next, we find the moles. We just divide the mass we were given, 40 grams, by that molar mass, and we get 0.25 moles. And then the big one, the unit conversion. 100 cubic centimeters becomes 0.1 decimeters cubed. Finally, we just plug it all into our formula, 0.25 moles divided by 0.1 decimeters cubed, and our answer is 2.5 moles per decimeters cubed. Listen up, because this is probably the number one spot where people lose easy points. Exam setters absolutely love to give you the volume in cubic centimeters just to see if you're paying attention. So you must always convert it to decimeters cubed before you calculate. I'm telling you, double check your units every single time. All right, you've got the theory, you've seen the formula in action. Now for the real deal. Applying everything we've learned to actual past exam questions. This is where it all comes together. Here's our first one, a real question straight from a WAEC paper. It's a two-parter, a definition, which we've totally got covered, and then a calculation. But hang on, did you spot the little trick they threw in there? They want the answer in moles per 100 grams of water, not moles per dm cubed. Let's see how we handle that. So the definition part is easy. For the math, we start by finding the molar mass of calcium chloride, which is 111 grams per mole. Simple enough. Then we find the moles. 1.11 grams divided by 111 gives us a nice round 0.01 moles. And now for that final step. The question gives us the amount in 20 grams of water, but asks for it in 100 grams. So you just have to think, if we've got 0.01 moles in 20 grams, how many would that be in 100 grams? We just scale it up, multiply by 5, and that gives us our final answer, 0.05 moles per 100 grams of water. And yeah, that brings us to a huge pro tip. Always read the question carefully to see exactly what units they want for the final answer. They might ask for moles per dm cubed, grams per 100 grams, or in this case, moles per 100 grams. Matching your units to what the question demands is absolutely essential. All right, let's switch gears a bit. This next one from JAMB isn't a math problem. It's a why problem. It asks, why does a solid usually dissolve better in hot water? Take a good look at those options. Which one do you think really gets to the heart of it? The correct answer here is D. And here's the logic. See, at the end of the day, heat is just energy, kinetic energy to be specific. When you heat the water, you're giving all those little solute particles more energy to vibrate and move around like crazy. This extra energy helps them literally break free from the bonds holding them together in their solid form, which lets them dissociate and mix into the solvent. So remember that soda we talked about right at the start? We finally have the answer. It's all about that third factor we mentioned, pressure. Inside that sealed bottle, the pressure is super high, and that high pressure forces a ton of carbon dioxide gas to dissolve in the liquid. The second you twist that cap, the pressure is released. The solubility of the gas just tanks, and it all rushes to escape as bubbles. And boom, that's Henry's law right there, happening in your soda can. Whew, we've gone through a lot, right? So let's wrap this up and lock in the most important stuff you need to take with you for exam day. Think of this as your exam day cheat sheet. First, I'm going to say one more time, units. Units, units. Second, for exams like WAEC and NECO, make sure you practice with solubility curves. For JAMB, it's all about reasoning and the process of elimination. And finally, if you remember anything else, remember this. For solids, heat makes solubility go up. For gases, heat makes it go down. Look, at the end of the day, it really all boils down to this. Master the absolute basics. That means water's polarity, those three factors, and the main formula. If you have that foundation solid, everything else is just about getting the practice in. So, look, you've got the concepts, you've got the formulas, you have the strategy. The only question left is, are you ready to put in the work and solve those problems? I think you are. Good luck. For more practice questions and solutions, visit examkp.com.